Hello everyone and welcome to this tutorial for the Ruida CO2 laser controller. Whether you're new to laser cutting or looking to better your understanding for your control system, this guide will walk you through the functions and features this controller has to offer. Ruida controllers are known for being one of the most widely used control systems in the laser industry. They are reliable, precise, and offer a user-friendly interface with advanced capabilities. To power up the machine, we need to rotate the emergency stop button clockwise and release it. Once released, the machine will start up and automatically begin the homing sequence, during which the axis moves to the designated homing position where the limit switches activate and finish the homing sequence. Next, we can press the green laser switch button, which is located right beside the emergency stop button. This button activates the laser tube power supply and enables the laser beam, allowing the machine to perform laser operations. After powering the system, it is recommended to leave the machine idle for approximately 10 to 15 minutes. This warm-up period allows the machine and its components to stabilize and equalize any temperature differences, helping to ensure consistent performance and optimal operating conditions. In the bottom right section of the controller, we can locate the positioning buttons, the main 4-arrow buttons which move the laser head up and down, right and left. Right next to them we have the Z upwards and Z downward buttons, and with them we can control the height of the workbed or the honeycomb. On the opposite side of them we can locate the U plus and U minus buttons, which are responsible for controlling the rotary axis. Depending on the model, the position of the basic operation buttons and the numeric keypad may vary. Let's take a closer look at them and their functionality. The green button, Start Pause, can start up the production process or pause it. If we use this button to pause the process, we need to press it again when we are ready to resume the operation. The yellow button, Reset, is used to reset multiple operations on the machine. The red stop button completely stops the production, and if you use this button, you cannot resume your work. You can only start the process from the beginning with the start button. The button Pulse fires the laser beam while pressed. The laser beam will be produced continuously as long as we keep the pulse button pressed. The laser beam won't be generated if we haven't previously powered up the laser power supply with the green button. The menu button gives us access to all the settings and advanced parameters for the laser. The focus button is responsible for the autofocus function. The frame button is used to check in which region the laser will perform the operation and how much area it will process. The File button opens up a menu from which we can access all files in the controller's internal memory or access the USB stick. In this menu we can open and load any file and prepare it for processing. The Origin button is used for determining the origin point of our project. The Power button opens up a menu where we can input or adjust the values for the power of the beam. The Shift button is used in combination with other keys for secondary functions. The Speed button opens up a menu where we can change the speed with which the axes travel when we move them manually with the positioning arrows. The button Escape cancels or invalidates the change and backs us back to the previous screen or menu. The Enter button confirms any change we make, or it confirms a process when initiated. And the numeric buttons allow us to input any value. We can use the dot button for decimal values, and we can use the backwards arrow to delete, just like when we use the backspace button on a computer. We can also take a look at the screen. On the LCD display, we can notice multiple function zones, which give us a complete overview of the production process. In the left section of the display, there is a preview of the processed file in real time. In the upper right corner of the display is the file name, the laser beam power rating, the speed values, and the current X and Y coordinates. In the lower right corner, we have a section where the settings for each processing layer are displayed, the speed, the power, etc. And in the bottom line of the display is the information panel displaying the current state of the machine, the completion time, and status of PC connection. Let's take a look at the production procedure. So first step is to select the material which we're going to process and place it inside the laser's working area. Once the material has been positioned correctly, we need to perform the autofocus function. This process automatically measures and adjusts the distance between the surface of the material and the laser head to ensure optimal focusing conditions. To start the autofocus procedure, we need to press the focus button, which is located on the machine's controller. The controller will then ask us to confirm this operation by pressing the enter button. Once confirmed, the autofocus sequence begins. During this process, the machine bed gradually rises, moving the material towards the laser head and the autofocus sensor. When the surface of the material makes contact with the autofocus sensor, the machine automatically detects the correct focal distance and adjusts it. The bed then lowers slightly, positioning the material at the precise height required for accurate laser focusing. One very important detail to pay attention to while autofocusing is the position of the autofocus sensor while performing the operation. If the sensor isn't positioned directly on top of the material, there is a high probability for a collision to occur. If there isn't any material for the sensor to make contact with, the tip of the sensor might get lodged in the recesses of the honeycomb mesh. In this situation, there is nothing below the sensor switch, and the working table will continue to rise upwards until the button is pressed. Unfortunately, in these conditions, there is nothing that can press the button, which will result in the work table rising until it smashes into the laser head, with the potential to misalign and damage the components. So we must always be careful and double check everything before performing the procedure. Once the material is positioned and we've successfully performed the autofocus procedure, we can continue with importing our drawing/design and begin the production process. To import a drawing, we must previously prepare it in RDWorks, the software built for Ruida controllers. We cannot import a raw DXF file directly into a Ruida controller via the USB drive. The laser controller only natively understands proprietary machine files like .rd. To prepare a DXF file for production, first we must process it through the laser control software, which converts the vector lines into a machine-readable G-code file. The procedure is the following. First, we import our file into the software where we assign layers to the vectors, which according to the parameters determine what the laser needs to do. After we set up the values for every layer, we can continue with transferring the file into the machine's internal memory. We can do this in two ways. Either we send the file via USB cable or via USB drive. To transfer the file via cable, we need to press the download button in the lower right corner of the interface. Once we initiate the transfer, the software will ask us to name the file, which will help us locate the file in the laser's internal memory. When performing this kind of transfer, we need to make sure that the cable is connected with the PC USB port located on the right side of the machine. After the downloading is complete, we can locate our file in the machine's internal memory. We press the File button on the machine's controller and locate our file in the list. To transfer the file via USB stick, we need to save the processed file from RDWorks onto the flash drive itself. We do this by clicking the option Save to U file, which opens up a window where we can choose where to save the file, and we can also name it. We need to make sure that the flash drive is formatted in FAT32 file allocation type, or the laser controller might not recognize it. After this, we plug the drive directly into the U-disk port, and we copy the file into internal memory. To complete the transfer, or to copy the file, we need to press the File button on the controller. This opens up a new menu where we need to navigate with the right arrow key and select the U-disk Plus option. We can scroll through the list using the up and down arrows until we locate our file. We need to scroll right to select the option Copy to Memory, which transfers the selected file from the USB disk into the machine's internal memory. Once copied, we are free to remove the USB drive. Next, we press the File button on the controller again to locate the file that we just transferred. The laser cannot run files directly from the flash drive, so we need to locate it in the controller's internal memory. Once we open the list, we scroll through it using the up and down arrow keys, and we find and select our file. Now the display will show the layout and vectors of our design. Its layers, its parameters, they're also displayed. We assigned their value previously when we prepared this file in the software in RDWorks. The only remaining thing to do is to run the file. Before we do that, we need to assign an origin point so that the machine knows where the workpiece starts and in which area to perform the operation. We determine the origin point by positioning the laser head with our arrow keys in the designated corner of the workpiece. After this, we need to press the origin button on the controller, and with this the machine remembers the coordinates from where it needs to start the production process. We can make sure that the laser will work in the correct area by checking its path with the option frame. If we click this button, the laser head will start moving and show us in which area it will operate. The laser head will encircle the perimeter of the design without generating a laser beam. We need to observe the red positioning dot to make sure that the vectors fit ideally on the work surface. After we've made sure that the laser head is in its proper position, we can begin the production process.
This was the final step of the procedure, and with this you're fully prepared to use the laser's controllers and run files directly from it. I hope that you found this video helpful and that it made things easier for you. I'll see you again in some other video. Bye!